Okay, so for today's class, we are going to look at our applications of trig functions. So we're going to get into those word problems. But just to begin, you'll notice a review from our previous lesson. If we are looking at our graph, how can we create the equation of that? So I want you to take a minute to write for me the equation of this graph in both a sine function and in terms of a cosine function. So I'm going to give you a minute or two to do that now. Okay, let's see how we did. So let's look at some of these key properties. I know I have a maximum with a y value of 4. I have a minimum with a y value of -2. So my span from my max to my min from 4 down to -2 is 6 units. So half of that would give me an amplitude of 3. So again, that a value, our amplitude, is half of our height. To find the middle of our graph, I can start at -2 and I can add 3 to that, or I can start at my max of 4 and go down 3 units. Either way, I find out that the middle of my graph is at 1. So that equation of our axes that we have would be at y equals 1. Awesome. So I'm just going to clean that up a little bit. The next piece that we want to think about is how long does it take for one cycle to occur? And if I'm looking at that y-axis, I can see that I'm starting at the highest point of my graph and falling. And then I reach that highest point again, pi units later. And so I can think about that in terms of if my graph is now at pi, normally a sine or cosine function would take 2 pi units. So that's been cut in half to pi, so it's been horizontally stretched by a factor of a half, which means my k value would be 2. Again, for unsure of that, we have our trusty little equation. My period's pi. If I were to rearrange that, my pi's divide out, and I get a k value of 2. So awesome. So we have those key pieces of information, our amplitude, our shift up or down, and our k value, that horizontal stretch. So now we can think about what's happening with these equations. So since we're starting at our highest point and falling, I'm hoping that we recognized right away that our cosine function would be easily represented by that. So we have y equals 3 cos 2t plus 1. So that would be the function we could represent with the fewest number of transformations. But we've also been asked to write that sine function as well. So I'm going to just a few things. So we know our equation of our axes here. So I'll erase that line after, but that equation of our axes is at y equals 1. A few other key points I need to note: that a full rotation here takes pi units, which means each of these, my scale for each of those grids would be a pi by 4. So pi by 4, pi by 2, 3 pi by 4, and obviously 4 pi by 4, which would give me 1 pi. So now we're thinking I'm taking my original sine curve. So if I have vertically stretched it, horizontally stretched it, and shifted it up 1, my sine curve would occur at the equation of the axes of my y-axis, and it would rise, right? So here we're just drawing what my original sine curve would have looked like, but I need to now shift that left or right so that it actually matches with the graph that we have. So if I look at my curve in red, I can move that to the left pi by 4 units. So that would be one option that I could have in terms of stating this as a sine curve. So to the left, pi by 4. Or Maybe instead you went and you said, well, I can take that maximum and I can move it to the right 3 pi by 4. In either of those equations, if I shift it to the left pi by 4, my red graph will now represent the function I've been given. Or if I shift it to the right 3 pi by 4, it will also represent that function that I've been given. So in question 2, there's a lot going on in this question. So I want you to, as you read through it, circle, underline some key pieces of information for yourself. And then we're going to take that information and we're being asked to determine a function. So we're going to do 2 things. We're going to draw a sketch of this and we're going to create a function to represent that. So when I ask you to draw me a sketch for a word problem like this, what I'm not asking for is for you to draw for me a windmill, right? As you can tell, I don't teach art. Oh gosh. Okay, well, this windmill's having just an extra piece to it. Okay, so I'm not asking for a picture of a windmill, obviously. What I'm asking for is we're going to draw a sketch to represent what's happening for this windmill. Okay, but a few things to keep in mind. We have been told that point P is at the highest point and it's rotating. Okay, so a couple things I want us to look at though. If I were to rotate, as we're rotating, so we're dropped and then we're rotating around. So we're rotating around that point P and we're unraveling that circle that we see. So a couple of things that we can take from that horrible picture that I've drawn there, that we're starting at our highest point, and as this point P rotates around, it's creating that circle, which we know we can unravel to draw as a curve. And that would unravel to represent for us a sine or a cosine function, okay? So I'm going to get rid of that windmill that I have drawn there. So I know that I'm starting at the highest point and we're rotating and we're coming back up to that highest point. I hit a minimum. And so now there represents what that unraveling as we rotate around on that windmill could look like. So now let's start to use that information to label. So I'm hoping as you go through, okay, we know a few things. We know that we're dealing with our time is in seconds. So T is in seconds. And we have our height is going to be in meters. So I have my time is in seconds and my height is in meters. So that's good to know. A few other key pieces of information that I know it's going to take 12 seconds for that to occur. And I know that the center of my windmill is 6 meters and it has blades of 2 meters in length. So I should be able to write that I have 4 and 8. Those should be some key values on my graph. Okay? And so it's not going to cross the x-axis because we've been told that the center of our blade. So for some of you, you might want to include on there that center height is at 6 meters. That is the middle of my windmill. So to go back and draw, well, let's just pretend, okay? I don't know why my windmill looks like a flower, but anyways, okay? That windmill, we have the center of it is at 6 meters off the ground. And it has a blade that reaches to its highest point. That blade is 2 meters in length. So the highest point of that windmill is going to be 2 meters above the center. And my blade, when it rotates and reaches the lowest point, that blade is still 2 meters long. It does not change in size. So 2 meters from that center is going to be 4 meters, which is why obviously our windmill stays above the ground. Okay. And so those would be key pieces of information that we would want to use. So right away, from what we've been told, we know that blade is 2 meters in length. So from our center to the top, from our center to the bottom, we know that that's a height of 2 meters. So my amplitude is 2 meters. I know the middle spot of my curve, or in this case, that middle spot of that windmill has a height of 6 meters. So from my original axis at 0, that has been shifted up 6 meters and is now the middle portion of my graph. So that equation of the axes is at 6 meters. And now this last piece that we have is we have our period is 12 seconds. So we're going to talk about that again in a minute. So all of a sudden you'll notice our period has changed into time. So that should be raising a little red flag too, which I will come back and talk about. So here our period is 12 seconds. We know that that's equal to 2 pi by k. And if I rearrange and simplify, my k value for this function is pi by 6. Okay. So now to write the equation of our function, we have our height, our amplitude is 2. If we look at how our sketch has been drawn, we start at our highest point and we fall. So we hopefully are all agreeing that a function of a cosine function would be the easiest way to represent this. My k value is pi by 6 t, and we have shifted up 6 units. So we have now drawn a sketch of what this looks like, as well as given the equation of our function. So one last piece that I want to add to this, because I think it'll just help us kind of gain that full picture, is we have that one rotation takes 12 seconds. That half rotation, right, is going to be 6 seconds. So if we just think about what those key points are. Okay, so we can still break that into our quarters, so we can think about that in terms of time. Okay, so I feel like that might just help us to get that picture. I'm going to just include this equation of this axis just so you can see that at those key changes, but I would encourage us to remove that equation of our axes. Okay, so when we look at question B, it's asking what is the height of P at 5 seconds? So we know on our curve 5 seconds is going to be somewhere around here. So what is the height of P? So again, that P was at the top of our windmill and it's been rotating around. So at 5 seconds, so at this point, I'm hoping that we're still kind of going like, okay, but I'm not quite sure about this whole time in seconds on my axes. Okay, Miss Giddy, you just subbed in time in seconds, but when I go to answer this, when I'm dealing with cos of 5 pi by 6, well, that's an angle in radians, right? So if we're kind of thinking about this, okay, I just subbed 5 in for seconds, but then all of a sudden on our next line, we're saying cos of 5 pi by 6. I'm about to draw a unit circle for that because that's in radians. So if that's kind of causing a red flag for you and you're going like I believe you, but I'm not quite sure why, let's take a moment to talk about that, okay? So when we were dealing with our period equals 2 pi by k, that stretch factor of pi by 6 isn't just a stretch factor. It's also a unit conversion factor. Okay, so it actually converts for us so that now we can have an axis. In this case, our t-axis can be written in time and in seconds. So what do I mean by that? So when we think about, so I want you to think about your period equals 2 pi by k. So right now, our period is in seconds, our 2 pi is radians, and we have this k. As I rearrange, our k value also becomes a conversion for us. So our k is our conversion factor of putting things in radians per second, which you'll notice then if we have this pi by 6, that is our radians per second. So now, how does that work here? So again, I want you to think about this. Our k factor was this pi by 6, right? That was our k. It was also our conversion factor over here, right? It was changing things to radians per second. So now when I sub in my 5 for time, this is in seconds. This is in seconds. This is in radians. So now when I sub in my 5 for seconds, we notice that these seconds divide out and we are left with 5 pi by 6 radians, which is why we then can continue on and complete our math in radians. Okay, so if you were understanding everything up to this point and this deep dive, if you will, into that conversion factor starts to confuse you a bit, that's okay. I just wanted you to understand the math behind how did all of a sudden our axes go from being written in 2 pi or in radians, what we saw in all of our examples that we did yesterday for creating these equations, into all of a sudden we're now subbing in time in seconds and how we're sub that into our equation. Okay, so that's just kind of the background and the math behind that conversion factor and how we're able to have a scale here that's in time in seconds. Okay, so I'm just going to clean this up a bit and let's actually now answer the question. Okay. So since we want to write this for as exact as possible, whenever possible, we know we have our 5 pi by 6. It's going to rotate me into that second quadrant. And so that's going to give me a 2. The cos of 5 pi by 6 will be replaced with a negative root 3 over 2 plus 6. So 6 minus root 3. And since we don't describe height in that sense, it'll be approximately 4.27 meters, which when we look at our graph, checks out. Awesome. So that's what we're looking at there for question B. So now let's continue with that same type of information in question C. So what is the height of P at 40 seconds? So we could continue on, sub in 40 seconds now, and so we'll have 40 pi by 6 plus 6. Maybe you reduce that to 20 pi by 3 plus 6. And I'm going to say that doing that, we've kind of kept our blinders on. Okay, because if I'm asking you to write this for as exact as possible, in order to find out your 20 pi by 3, right, you're going to have to be rotating around until you find out what 20 pi by 3 rotations would be in order for us to find out that value of cos. However, I would argue that let's think about this in terms of its periodic. It repeats every 12 seconds. So if we have rotated for 40 seconds, if that takes 12 seconds per cycle, we have rotated 3 full cycles, because that gets us to 36, and we are 4 seconds in to that next cycle. So we are instead 4 seconds into our 4th cycle, right? We've completed 3 full cycles. So if this is periodic, instead of having to think about that work, I can say I am 4 seconds in to my cycle. Which we know is just 2 pi by 3, which you could have gone to right away. Which will give us 5 seconds. So what is the height of P at 40 seconds? Sorry, our height will be 5 meters. Awesome. So again, I can still bring this back to my first rotation, which will make it a lot easier for me to find the exact value when needed. Oh. So we're not quite done with this question yet. So all I've done is I've rewritten at the top of my page what our equation was that we were dealing with. So now we're being asked at what time is P exactly 7 meters above the ground? So again, if we're thinking about when is it exactly at 7 meters above the ground. So if we know this is a 6. So what we should be realizing is we should end up with 2 values of where it will be exactly 7 meters above the ground. All right, so this now just takes into account my height is 7. So now we're just solving our trig equations, right? Bring the 6 over, divide by 2. So I have cos of pi by 6t equals 1/2. So please keep in mind, this is the same as thinking of all of that as theta. So this is the same as thinking of this as cos theta is equal to 1/2, right? That pi by 6 is part of the angle. So we cannot divide that pi by 6 out right now. We have to think about cos theta is equal to 1/2. So I know cos is positive, where our adjacent side is positive. So we know that this will give us, normally we would answer that as theta equals pi by 3 or 5 pi by 3. But in this case, we have it as pi by 6t is really our theta. So I have a pi by 6t is equal to pi by 3, or pi by 6t is equal to 5 pi by 3. Now that we have dealt with our ratio and we found out what that is, we can now deal with our angle, right? We have pi by 6t is equal to pi by 3, at which point we can just do quick rearranging, right? I'll show the work, but you wouldn't have to. Divide both sides by pi by 6, which means we multiply by the reciprocal. Our pi's are going to divide out, and we have 2. So at what time is it exactly 7 meters above the ground? At 2 seconds. And same thing here. And at 10 seconds. So we have found 2 values for at what time is P exactly 7 meters above the ground. However, I would argue that you have not fully answered this question yet. It does not ask just for in the first rotation. It's asking at what time is this happening. It's not giving us any type of restriction there. So I can use my knowledge of these terminal arms, do not repeat, at regular intervals. So I should be having 2 statements here. And if we are just kind of looking straight ahead at things, we might be tempted to say, well, then time is equal to 2 plus 2 pi k, and time is equal to 10 plus 2 pi k, because we said, oh, there's a full rotation that has to occur. Except I'm going to say that is incorrect, because in order for one full rotation to occur, our units are every 12 seconds it takes for one full rotation to occur. So our answer here would be T is equal to 2 plus 12k, or T is equal to 10 plus 12k, because again, our time is in seconds there. So every 12 seconds later, we will reach that height of 7 meters. And since those terminal arms do not repeat at regular intervals, there's 2 different statements that we need to tell us when that will occur. So for question 3, I want you to take a minute, read through question 3 and 3a, and then I want you to draw for yourself a sketch and come up with an equation to represent that function. So again, please do not just draw me a picture of a Ferris wheel. I do not want to see your Ferris wheel, no matter how fabulous it is. I want to see your actual sketch of that curve. Okay, so let's see how we're doing with this. So few key pieces of information. We know we have a diameter of 18 meters of this Ferris wheel. So the full distance of that Ferris wheel is 18 meters. So right away from reading that, I know if the entire distance of the Ferris wheel is 18 meters, half of that is going to be 9. So my amplitude of this will be 9. It travels at a rate of 5 revolutions for every 2 minutes. So I'm going to turn that into seconds. So I'm going to take 120 seconds, which would be my 2 minutes, divide that by 5 to know that it's going to take 24 seconds for 1 revolution. And I know at the bottom of the ride, the passenger is 2 meters above the ground. So I know that's going to be the lowest spot on my graph is 2 meters. I know that my entire diameter of the Ferris wheel is 18. So I'm going to add that to my 2, which means that my highest point is going to be 20. And then to find that equation of the axes, how far has my equation shifted up? Well, again, we know that if my lowest point is 2 and my amplitude is 9, if I go 2 plus 9, that's going to put me at the middle of my graph at 11. So with all of that information, I know my amplitude is 9. I have my equation of my axes is at 11. I know it's going to take 24 seconds for 1 rotation to occur. And so I can find out that the period is equal to 2 pi by k. Again, that's also our conversion factor, which is allowing us to write our axes in terms of seconds. So we know our period is 24. We rearrange, we know that our k value is pi by 12. You may ask, okay, but how did you know that they were starting at the ground? Well, I'd encourage you to think about the last time you rode a Ferris wheel, that you did not just take a running start and fling yourself at the Ferris wheel and just hop on partway through, right? You get on at the bottom of the Ferris wheel and then it rotates around. So again, just a little common sense on that aspect of picture yourself going on a Ferris wheel, and I have yet to see someone just take a running start to run at one. So yes. Okay, so since we're starting at the lowest point and our curve is increasing, I'm hoping we can notice that if we use a reflected coast curve, that we can write that in a pretty simple form without having to include a phase shift. Could you write this as a sine curve and include a phase shift? Absolutely. I would just argue that you're doing a lot more work than what you would need to. You'll notice with these questions, I have not asked you to write it specifically as a sine or a cosine function. So my hope is that you're going to use the most efficient formula, and often that formula does not include a phase shift. At times, can we avoid a phase shift? No. Regardless of our sine or our cos, we might need one depending on the function we've been given. However, when possible, I certainly think it's easier to just continue with an equation without a phase shift, especially since I know I'm going to be working with this further. Okay, so hopefully you had that equation of h is equal to -9 cos pi by 12t plus 11. So once the passenger reaches the top, how long does it take for her to get below 10 meters? So I'm just going to give us more room because we're going to need it. Okay, so a few things are happening here. Let's find out first when the passenger is at a height of 10 meters. And then we can take that time and we know she's at the top. Sorry, I lost my train of thought there for a second. When does she reach the top? Once she reaches the top, how long does it take for her to get below 10 meters? So first, let's find out when she's at a height of 10 meters, and then we can deal with her actually being at the top and what that means. Okay, so first things first, let's let our height equal 10 meters. Awesome. So I want to give you a minute for you to be able to try to rearrange this and get some type of value for me. So I'm going to just pause for a moment and take a minute or two, stumble your way through it. If you have any questions, let me know. Okay, let's see how we're doing. So let's rearrange. Just get caught up to where you are. So we have cos pi by 12t is equal to 1/9. So again, please keep in mind this pi by 12t is a package deal. You're picturing it as your theta, right? So you're thinking I just have cos theta is equal to 1/9. I do not have a special triangle for that, so I am going to do inverse cos and type that into my calculator, right? So that we're doing the exact same thing, except this time when we get our answer, we know theta is really equal to pi by 12. Okay, so a few things to go with that. I know cos is positive, where its adjacent side is positive. So when I go inverse cos, I can find my related acute angle here. I know my related acute angle is going to be 1.46. So in this case, I am going to have pi by 12t is equal to 1.46 because my related acute angle is in fact one of my answers here because it's in the first quadrant. And then my other option is pi by 12t is equal to 2 pi minus 1.46. So at this point, again, please keep in mind that pi by 12, t is equaling our 1.46. Okay, our pi by 12 is our conversion factor. That 1.46 is in radians. So in terms of me writing out this 2 pi minus 1.46, that 1.46 is currently in radians. So I have to stick with 2 pi minus 1.46 because all of this here is written in radians. We have not yet converted that into time in seconds yet. Okay, so I just want to be very clear with that. So at this point, I'm going to have 1.46 times 12, divide that by pi, and I'm going to get that time is approximately at 5.58 seconds. So our passenger is a height of 10 meters at 5.58 seconds, or I'm going to have 12 times my 2 pi minus 1.46 all over pi, and I'm going to get that the next time that they are at a height of 10 meters is at 18.42 seconds. Okay, so now let's take some time to interpret this. We know, so there's a few things that are happening here. We know that those are going to be key values on our graph. We know if 24 seconds is one full rotation, half of that would be 12 seconds. And then I can just break these down into its quarters to help me see a few things here. So right away, we notice once the passenger reaches the top, how long does it take for her to get below 10 meters? Well, once they reach the top, well, we know that they're at a height of 10 meters. At 5.58 seconds, well, we haven't reached the top yet. We're still on our way to the top. So this answer here is going to be inadmissible. We have not reached the top yet. So now to actually calculate our value, once we've reached the top, which is at 12 seconds, how long does it take to get below 10 meters? Well, we know we hit a height of 10 meters at 18.42 seconds. So if I take, therefore, 18.42 minus 12, we get 6.42 seconds. If that's the answer that you got, you are so close. We're now just dealing again with some of those itty-bitty rounding, right? Like if this had really been 18.42321.579, something like that in our calculator. So we rounded down because we followed our rounding rules. But what we notice is if I just round it to 18.42, that would still leave me a little bit above my height of 10 meters. So the quick fix to this would just be, therefore, at 6.43 seconds is how long it would take from being at the top of the Ferris wheel to immediately below 10 meters. And so now we've been able to incorporate creating equations from our sketch, using those equations to solve trig equations, and then interpreting that to match the values that we're looking at. And again, you'll notice, like I mentioned here, we were still dealing in radians. Once we multiplied by 12 divided by pi on our next step here, we used that conversion factor, and that's how we got to our time in seconds. So again, just kind of tying all of that together for us.